Hey Zamrez, how are you?
Why
Hello,
is it why,
you can hear me, bache?
why is it a new link every class?
What happened? I did not like. I don't understand.
Why is it a new link every class?
Wait, don't even ask here. There is some glitch in that link. The link is not opening itself. Maybe they'll fix this problem. I have addressed. They will fix this problem. Don't worry. I was also waiting. You were also waiting. So the link was not working. There was some problem with the link. Chalo, without wasting any time, we'll start the class. Zamrez. Zamrez, one more thing. Did you go through the previous chapters? All the concepts are clear, right?
Yes.
Okay. So we are going to start a new chapter today. Which chapter? Chapter 10, physical change and the chemical change. Okay.
Yes.
Okay. Sure. I hope you're sitting with your pen and a paper. Please do. Bring it. Fatafat, fatafat. A pen and a paper. So we'll start with the topic for the day. What is changes for you, Zamrez?
Changes so- something that something that something that
Something that
something that uh, turns something or like turns physically or chemically into something else.
something that dash physically chemically. I did not hear the middle word. Something.
That turns
Yeah, wear your headphones. I'm not. I just hear the
that turns.
that turns.
So physical changes are it's when something that turns into something
Okay.
which is
So can I say use the word alteration? Alteration is okay. When there is any kind of alteration, that is change. Okay. So now since we are talking about physical change and chemical change, it is related to chemistry. Okay. So when matter alters, that's change. Okay. So please note this point down. Alteration of matter is change. Please note this point down.
just
Done. Done.
Yes.
Now we will talk about types of change. Can you tell me what are the two types of changes?
Reversible and irreversible.
Physical change
Chemical sense.
and chemical change. Okay. So, Zamrez, suppose after your annual exam, you thought of changing your look. You wanted a new haircut. You took a new stylish haircut. You did a little bit of grooming. So, what kind of change is that?
So,
Physical change, where you are changing your physicality, your physical appearance. That's a physical change. Now, when will it be a chemical change, Zamrez?
it's when something changes something changes into a chemical changes its chemical composition.
Yeah, kind of correct. When your chemistry will change, right? When some kind of hormones will change in you, when some kind of enzymatic reactions will change in you, that is when you are changing chemically. Okay. For example, when you go to grade 10, 11, when you hit adolescence, there will be secretion of certain kind of hormones. Okay. That will bring on certain kind of change in you. Those will be chemical changes. Okay. Now, the basics are done. We will now enter into the next slide. Just a second. I have to rub the previous slide then. Why is not my eraser working? Just a second. Can you see my screen?
Yes.
So now we will be talking about the physical changes, the changes that involves changes in the physical property of a substance. Okay, when there is any kind of alteration in the physical change. Physical change matlab change in shape, change in size, change in color, appearance, state. Okay, so when ice melt into water, that's a physical change. Because at the end of the day, ice is also made up of water and water is also water. Just the compact form and the little distant form. Right, Ms. Andres? Now, when I talk of, I will show you something today. Very stupid maybe, but I've thought that I should share it with you. Can you see me? Can you see me? What is this?
Paper.
Paper.
You're gonna tear it.
Huh?
You're
No,
gonna
I will not share it. I will not share it. No, what is this? Please tell me that you could identify it.
uh, it's an iron, so you can like heat up your clothes.
It, what is it?
The iron thing can heat up your clothes.
No, I made a plane which you could not identify. But my plane was good. Problem is in your identification.
I've never seen a plane like that flies upside down.
Hmm. So what did I do? I changed the state, right?
Changed its shape.
I did a alteration in the paper, but it's a physical change. I changed the shape, right? I changed the form. If I color it, again, that will be a change. I will be changing the color, right? So these are physical changes.
Won't that be a nothing?
Huh?
Nothing. It was a stupid question.
I'm not able to hear you properly, Zamrez.
It's nothing. I immediately clarified my question before asking it.
You want to clarify your question?
No, I already clarified it myself.
Yeah, you already clarified yourself. Moving on. Now I will be, now please get back to the screen. I hope you can see my screen.
Yes.
Yeah. So that is any kind of change in size, shape, appearance, or state without altering the chemical composition. So I am not going to play with its chemistry. And you gave a very beautiful example of tearing a paper. Tearing a paper is also a physical change, because at the end of the day, the pieces that I'm getting is also a paper. So there is no alteration in the chemistry. And I am not getting anything new out of it. It was a bigger paper and a smaller paper. I am not getting any new kind of product having a new chemical property. So it's the same thing. So these kind of changes will be physical change. Okay. One more point, very, very important point to note here is it is usually a reversible process. Zamrez, I a few minutes back told you that if you cut your hair and groom yourself, you will be changing your physical appearance. But suppose your some kind of exams come and you forgot to do your grooming next, what will happen? The hairs are going to grow back, right? Hmm. Just a second, the phrase. The hair is going to grow back.
Yes.
Okay. So at that time, you will gain your appearance back, correct? So you will, the haircut was a reversible process. I can solidify a liquid and get a ice. I can melt a ice and get my water back. Again, a reversible process, right? So any kind of physical change will be a reversible process. Can you please note this down, this point, that any kind of change which is reversible, any kind of change which is reversible.
Yes. All reversible changes are physical changes.
Yeah, you
All
can frame. Yeah, you can frame your concept. No problem. Just the concept has to be the same. Done.
yes.
The points are noted, whatever you understood till now.
Yes.
Okay. Now, moving on to my next slide is we will be talking about the characteristics of physical change. It is just the repetition. First of all, you have to understand that there is no formation of no new product. It's the same thing. Okay. Maybe an altered form of the same thing. Now, second point, as you have already mentioned, that it is a reversible process. There is no change in the chemistry. And, and what is next?
No new substance is formed.
Yes. Now, moving on to some of the examples, they have given a very basic example of melting of voice, boiling of water, paper cutting, dissolving salt in water, and stuff. But now we will be taking some of the major examples as well. So, next, we will be talking about a very big physical change, that is tearing of a paper. But chalo, we will take this up in the chemical change. When you tear a paper, you get small pieces of the same paper. So it's a physical change. When you crush a ice cube, when you take ice cubes and put it in mixie and get a powdered form of ice, the chemistry of the crystal ice and the chemistry of the powdered ice is the same. There is no change. So that is also a physical change. Done? Moving on. Okay. Now, here we will be talking about the process of crystallization. In crystallization, what happens?
It's when
Suppose you have a water in that there are a lot of salts that are dissolved. Okay. And when you heat the water, what will happen? The water will evaporate, correct? And at the end, what will you get?
salt.
You will get a white precipitate. And that precipitate is obviously the salt. Okay. Is it a reversible process?
Yeah.
What if you know about the condensation process? Do you know about the condensation process? While heating, what if I put a lid over it? Will not the water be coming back? So it is somewhere a reversible process. Similarly, yeah, tell me.
Salt.
Hmm?
About the salt.
Salt will again get dissolved in the water. So it
But
will,
won't be in the same form that it was before it was dissolved.
Zamrez, can you please come near to your mic, speaker?
But it was added to the water. It was in a different physical form after it
No,
was
it will
heated.
not be a different physical form. It will just be the same. There will be no change. The similar thing happens in in our earth as well. How do we get oceanic salts? By the evaporation, right? Now, when it rains, rains is a form of condensation. The salt will get dissolved in the oceanic water as well. So there is no change. है ना? Sure. Moving on to the next. So crystallization process is very important. If you want, you can note this down because it is there at the end of your NCRT. I'm dealing it now. Okay. Now moving on, there are certain examples given here. Breaking of glass, folding of paper, breaking of eggs, chopping wood, melting ice, boiling water. They all are physical changes. Okay. If you want, you can give me a few physical change, example of physical change, which is not mentioned here, obviously.
Candle melting.
Candle melting into wax. Yeah, that's a physical change. But burning of candle is a, think about it. Burning of candle is,
Chemical.
yes, very good. Burning of candle is a chemical change, but getting a wax is a is a physical change. Very beautiful examples, Zamrez. Anything else that you can think of?
Butter.
Water, what?
Butter.
Butter. Melting of butter? Yeah, good point. Very good. So I hope the physical change concept is clear to you. Now we will move on to the chemical change wala concept. A very, very reversible process. What happens here? Physical process was a reversible process, right? You can get back your normal things. Here it is a irreversible process. Point number one. Point number two, here you are changing the chemistry of a substance. There in physical change, we were not touching the chemistry of any matter, right? Here we are altering the chemistry. And when I'm altering the chemistry of a matter, what am I getting? I am getting a completely new thing. Okay? Just a second. I will give me 1 minute. This is again Zamrez. I'll share my screen. My few slides got deleted. That is why I had to stop. I hope you can see my slide.
Yes.
Yeah. So there are certain points that are very clear here that first of all, it is going to change the chemistry, alter the chemistry. Next is it is a irreversible change. You are not going to change your decision even if you want, now nothing can be undone. The third thing is you are going to get a new substance. All these three properties are very, very contradictory to our previous discussion of physical change, right? Right, Zamrez? Can you just note down these 3 points about chemical change? Just these 3 points, whatever we discuss now. Done? Yeah. Have you noted these points? Just check. It is just for your checking. Have you noted these points shown on your screen?
Yes.
Okay. Now, you just now told me that you told that when I changed my paper into a plane, you told that that's a physical change. Or else you gave an example that tearing of a paper you told is a physical change, right? What if
Yeah.
I burn it?
Chemical change.
That's a chemical change. And about candle also, you just said that, ma'am, changing of wax and candle, they are physical change, but burning of a candle is a chemical change. Apart from that, any other chemical change that you know? Cooking of food.
Yes.
Food cooking is the very big chemistry, right? Now, apart from that, I told you that cutting a log of wood is a physical change, but burning a log of wood is a chemical change. Okay. Now, rusting of iron, that will be a big discussion that will be taking up little later. Souring of milk, when I convert milk into curd, that also involves chemistry. Okay. Certain acids will be released in the milk that will cause the curding of the milk. Okay, so chemical reactions are involved. So first of all is the caramelization of the sugar. I just told you that converting sugar into a powdered sugar is a physical change, but caramelizing it is a chemical change, because I am not going to get back my powdered sugar. Done? Now moving on. Okay, one more example I want to add here, which is not given, is if I have a copper sulfate solution. You know this, the color of a copper sulfate solution?
It's a blue liquid.
It's a blue liquid. Not a copper sulfate. Wait. Chalo, copper sulfate. So it is going to be a blue color liquid. And you have a iron nail. You have a iron nail. Okay. Now, if you put this iron nail inside the copper sulfate solution, what will happen? Any idea?
Displacement. Wait. Yeah, displacement.
Yeah, displacement reaction, very beautifully quoted. But what will be the change that you will be observing?
So then how I learned it was that the iron will kick out copper as a bully, and it will take its place in copper.
What will be the change in the color of this liquid? This was a blue color liquid.
White?
Huh?
The copper of iron sulfate. The color of iron sulfate.
Will be green. It is going to be green. And you will find a brown color deposition
Yes.
over the iron. That you guessed correct. Now, what is the chemistry behind it?
Brownish red.
Yeah, brownish red. Yes, you are right. Brownish red color. What is the chemistry behind it? CuSO4 plus Fe gives.
Fe gives a FeSO4 plus
Very good.
FeSO4 plus Cu.
Cu. Okay.
I'm also gonna take extra time.
Yeah, I will be taking your extra time. I have to finish this. Okay, I will not take much.
10 minutes.
Yeah, okay. ठीक है? This much is clear. Now I want to get back to this example as well. Heating a mixture of iron and sulfur. You can see here a sulfur powder and the iron fillings. What will happen? There will be formation of iron sulfide FeS.
Yes.
This is FeS.
Yes.
And obviously the FeS properties will not match with the initial sulfur and the initial iron. Correct? So, and I am not going to get back my Fe and S. So it's again a chemical change. Okay. Now, moving on to milk of magnesium ribbon burning. The picture is given here. Magnesium ribbons are usually thin shaped ribbons. Itte patle patle. They're usually thin shaped ribbons. When they are ignited, what happens?
It will give like a white glow.
Yes, it will give a white glow. It's actually not a glow, it's a fume. It's a radiant fume. Okay. So what is the chemistry behind it? When I'm heating something, I am oxidizing it.
This is UV rays.
Not UV rays, Baba. It's not a UV rays are not involved here because I'm providing a energy as heat. Okay. So when magnesium, I am heating magnesium, it means that I'm oxidizing it. So what will be the form? What is the chemistry of the fume? Magnesium oxide. Okay? Magnesium oxide, that is MgO. Now, Mg plus O2 will give us 2MgO. Now, what if I dissolve it in water? What will I get?
Dissolve magnesium
hydroxide. Yeah. What is the property of magnesium hydroxide in the last class we just read? Is it an acid or a base?
It is a base.
Very good. It's a base. Its nature is basic. Okay? Done?
Yes.
Now, moving on. Burning of crackers is also a
Combustion. Yeah.
combustion. Any kind of combustion will be a chemical change. Okay? Souring of vegetables. I will not say souring. I will say rot, spoilage of any kind of fruit is also a chemical change. How can I say that?
Plus
Why do you think mama keeps food in fridge after cooking?
so it won't get spoiled.
To avoid spoilage, yes. But what has it to do with the fridge? What does fridge do?
It kills all the germs that spoil
It
the
kills all the germs and the bacteria. Yes. What does these germs and the bacteria do?
they they eat they eat the foods.
They don't eat the food particularly, but they release certain kind of chemicals. These chemicals react with the coating of the fruit that cause the spoilage. Okay. Whenever you eat anything spoil, you'll always get a sour taste. Whenever you eat, to test that anything has got spoiled or not, we usually taste it. And whenever we get a sour taste, it's clear that the food has gone.
You get
The food has rot.
you
Huh?
get diarrhea. Why would you test it out?
Why?
You get food poisoned.
No, 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 no. You will not taste. I'm just telling you the science behind it. Because I have tasted when I was small, unknowingly.
You get food poisoned.
No, I had a strong immunity. But don't try this stunt at home.
Nah.
Okay. Now, moving on. Neutralization, what we learned in the last class, acid plus base is equals to salt plus water. That is also a chemical change. Correct? Ozone. What happens in ozone?
Can we breathe ozone?
Huh?
Can we breathe ozone?
We can breathe ozone, yes. But when we breathe ozone, it's harmful. We should not breathe ozone.
But it's made of oxygen.
It is made up of oxygen, but it is supposed to be present in the stratosphere. You know what's a stratosphere? It is above the atmosphere.
Yes. But what if we have ozone and that made ozone? And what happens if we
No,
breathe
I'll tell you a very beautiful fact about this ozone. Ozone is supposed to be present in the outer layer of our Earth. They're supposed to protect us. But now, due to pollution, what is happening? This O3 molecule is breaking down. What is the chemical formula of ozone? Ozone is O3.
O3?
Yeah. So because of pollution, what is happening? O3 molecule is breaking down into O2 and O. And we are actually inhaling this O, which is harmful.
How is O harmful?
It can cause eye irritation, redness of eye.
Then isn't it made of oxygen?
It's a nascent oxygen. Nascent matlab a single molecule of oxygen, which is not good. Okay? Not only that, it can cause various kind of cancers as well. It's that lethal. Skin rashes. Skin rashes are okay. Nowadays, if you go out in the sun, you might feel that your skin is burning, right? You will feel that you want to itch your skin. Ask your dad when he was small, when he used to go out in the sun, he would not feel the same. It's because the effect of the ozone breaking. Okay. Now, that is what? Change in ozone, that is, now I will read the point. Change of oxygen to ozone in the upper atmosphere is also a chemical change because oxygen and ozone are different substance. That is what I was talking of.
Then what substance is O4?
O4 does not exist. See, O4 will not exist. Why? Because if there is O4, they will convert themselves into O2 plus O2. Okay?
Chemistry has so many exceptions.
Yes, they do have. Okay? If they have O4, they will tend to convert. But if they have O3, they will first convert into O2 and O. If I heat it more, then this O2 will also convert into more O, O, O.
Oh.
Oh. Okay.
Yes.
Chalo. Now moving on to a very, very important topic, that is rusting of iron. Rusting of iron is again a redox reaction. It's mostly oxidation. It's an oxidation process. When oxygen is oxidized in presence of humidity, that is when rust is formed. Rust is nothing but ferric oxide or iron oxide. Okay, FeO3. Clear? Clear?
Yes.
Okay. Now can you please note down the formula of rusting? It's very important.
Isn't it?
Huh, Baba?
Okay.
It is not a balanced chemical reaction. Don't worry. The balancing is not there in your course. And just note down the points about rusting of iron. It's very important.
Where does the hydrogen go?
It is not a balanced chemical reaction. That is what I'm saying. There will be more product. Rusting is a long chemical
Like I
formula.
know how to balance equations, but
It's
with a
not. You want me to show you a balanced chemical equation? It will be a long one then. No, you don't want? Chalo. The full formula of rust, since you have asked for it and you have triggered me. You should not have.
Well, and I actually have balanced iron. It's like actually I've balanced iron oxide without water though.
Actually, the chemical formula is like this.
Actually, I'm not able to understand.
It is known as what do I say? Point of attachment. The H2O just gets attached to it. Okay? Now, moving on. How can you prevent rusting? You have to do galvanization. Simple way. Okay? What I'm going to do in galvanization, I'm going to coat it. Okay? What will I coat it with and why do I coat it with? I can coat it with zinc or chromium. These are the two metals that please note this point down. There are only two things that can be used in galvanization. First is by putting a layer of zinc or by putting a layer of chromium.
Which is harder now, steel or iron?
That is alloy.
Which is actually harder, steel or
Steel and iron is alloy, Baba. That will come later. Okay. Now, what does it do? Why do we do this kind of thing?
even
We
rust?
don't want the iron to come in contact with the oxygen and the humidity of the nature. So we put zinc in it. Ki bhai, whatever are the oxygen and the humidity that is going to react with the zinc, my iron will be saved. Okay? Same goes with chromium. So here, how can I prevent rusting? There is a basic principle behind it. My principle is cut off iron from oxygen and water. If I do not allow Fe to come in contact with humidity and water, I can prevent rusting. Okay? Now, if I put a layer of oil paint, what will happen? Oil paint will be resistant to water, correct? And when I'm closing the pores, obviously oxygen will also not come and penetrate it, right? So by painting also, I can protect my metal from getting rusted. ठीक है? Now, a basic galvanized iron is used in pipelines. If I use the non-galvanized iron or a rusted iron, what will happen? It is going to break apart because the strength goes when I'm putting it under rusting. ठीक है? Now, next is the essential conditions. We have already discussed. It is going to be moisture and air. ठीक है? Now, what can increase or fasten the process of rusting? It is going to be obviously high moisture content, high oxygen content. Apart from that, it is going to be salts. What do you think? How do salts promote rusting? What do you think about it?
The salts come from ocean water.
Do you know about cathode and anode? Huh? Okay. They will have positive and a negative charge.
Okay.
Okay. They will always have a positive and a negative charge. And whenever, so they will have ions, positive ions and negative ions. And when I'm going to heat the salt, they are going to split into, so the salt, when it is heated, it will split into positive ion and negative ion. Okay? And when they split, what will happen? You know about oxidation and reduction?
Wait, not reduction.
Addition of loss, Leo. You know about Leo? Loss of electron is oxidation. Okay? So what will happen? These ions are going to react with the iron and will cause its oxidation, causing the rusting process. Salts will be broken down into positive and negative ions, and these ions are further going to react with the iron, causing it to rust. ठीक है? Done? Can you just note down this particular slide? This is important. Let me know once you are done.
Okay. Noted repeated water rusts iron.
Sorry?
Noted.
Water.
Noted.
Okay, sorry. Noted. Now we will talk about the difference between physical and chemical change. Will you tell me the difference? You know most of it.
Physical change is a change that changes the physical composition. A chemical change can change the physical composition.
Physical change is also change in physical composition. Chemical change is also change in physical
The
composition.
chemical change can also change the physical composition, but most importantly, it changes the chemical composition.
Yes. Next. Based on reversibility.
So usually physical changes are reversible and all chemical changes are irreversible.
Okay. New product.
Chemical changes, new substances form. Physical changes, it's the same substance. It is kind of repeated from the chemical effect.
See, that's a division. Now tell me, where do you think I will get energy? In which kind of change will I get energy?
Chemical.
Chemical. Just note this point down because this is an addition. In chemical change, you will get absorption and emission of heat energy. That is not possible in physical change. Can we do question answers and then we are done?
What type of change occurs at the molecule level? Chemical change.
Very good. Fast. Quick.
Physical change. Physical
Hmm?
change. Physical
Physical.
change.
Yeah. Next.
Chemical change.
Next.
Chemical change.
Next.
Physical change.
Yeah. Next.
Weight. Size.
Which of the following examples of a physical property checks
Weight and size.
weight and size? Okay. What about odor?
Sometimes if something smells in the
Odor is due to change in the chemistry of the chemicals in your body. So you are right. It's not odor. Next.
True.
Next.
My food changes color. My microwave exploded. My dog. My homework ate.
My homework burned in a fire. That's your dream, right? My homework should not exist.
I'm surprised that Olympiad success made these things. Whoever made this question should get out Oscar and it is.
Yes. Tell me.
My foot changes A.
My food changes color. That's a chemical change.
Actually, no. Something. Wait. Yeah. It's all of them are wrong. I can't. Physical
You have
change
to
is
find
no.
the correct one. My microwave exploded is a chemical change, obviously.
Oh, it's C.
Chemical. My dog ate my homework.
Some soggy, sticky, mixes with all the other things.
In other way, yes, you are not wrong because you are not going to get it back because that will go in the poop of the dog in the next day.
Yeah, it goes in the poo of the dog, meaning that it changes its chemical change. No way you can make no way poop and a piece of paper are made of the same thing.
Funny example, by the way. Chalo, we'll leave this question. Let's go to this.
And gases condense and liquids freeze. Its liquids freeze. Energy stays the same.
Yes. Next.
Chemical change.
Very good. So,
Bye,
Zamrez,
ma'am. Thank
bye
you.
bye. Yes, we are done. Bye.
Bye.